So today we'll talk about my favorite topic is a churn model. Okay. This whole lecture will be divided into three different segments. One is the concept one. So today we'll discuss that, the concept. Second is the coding, that will come later. Third is end to end model building. So end-to-end model building is basically in there what you will know that how the data engineering will be involved here, how the data scientist will be involved here, how the data analyst will be here, and the business side will be, so BA will be involved here. Okay, so that basically will be three different segment. I would like to build this lecture on basis of that, right? So first of all, we have to know what is actually churn mean, or what is actually the understanding about the business perspective of the churn is. So churn is basically whenever the business has a subscription based. So it could be anything like big subscription company like Netflix or Amazon, right? Even like Rogers, which is a telco company, like telecommunication company in Canada. So what they do is basically they have a customer, and basically the customer pay them is a monthly basis, and based on that they actually get the money. So that's basically a subscription based model in the business model. But the subscription based business model, the customer is the main key, that how many customer you are holding or you are capturing for a longer time period, and you have to actually understand what the customer are trying to say from a data perspective, else they might leave you and then they can go to the competitor, right? So that's basically typical way the business looks at there. In data science, the most interesting part is that you can actually predict that which customer is going to stay with stay with you in the next month or next couple of months, right? So there are kind of signals, you can find it out from the data. Or there's one more thing is those who customer is already kind of left, you win back is those who already churn and win them back, right? So giving them some discount or giving them a better offer, you can win them back. Okay, so the overall idea is here to understand from a business perspective, and starts from a business perspective, then mathematics and statistics perspective, like stats perspective, how it works, how you'll be designing the problem, and from there, and we'll try to learn how we can do the coding. Okay, now we'll talk about the data table. Okay, so the data table is basically what we are talking about is the business will use this data table for their purposes, that those who customer churn and non-churn, they will decide the strategy they want to build it there. Before we go there, so this problem can be actually used for two purposes, just to write it down. One is churn and one is win back. Okay, so the churn is those who are having a propensity, so which is basically the future thing, right? So future, you are predicting that who will going to churn, and the win back is that's already done, the past, right? Already gone. Okay, so your customer is already gone, so you are looking for them, that how you can win back from there. Okay, so normally in these cases what happen is the data, we are talking about the data table. So the data table, how it's happened, that there would be a customer ID. Okay, so this is a unique ID. Then there will be probability of churn. So what is the probability of churn? Then there would be threshold value, and there will be a churn yes and no. So basically you will decide that if that person churn there. So suppose XYZ 1 2 3, the probability of churn is 0.56, 0.5 is your threshold value. So basically if this value is less than this, then it will be not churn. But for these particularly cases, actually it's more than the other value. So it will be 1 here, consider as a churn. Image 3 5 6, another one is 3, even threshold value is here. So 0.3 is basically less than 0.5, so this will be 0. Same thing about HZ alpha beta 3, and then if it is 0.35, which is less than 0.5, and this will be 0 again. So what is happening is basically you are looking at a different data sets, the row of the data, and you are looking at that if it is a 0 and 1, how they will be looking at. Okay, so like how the business will be take care of these things. Okay, so particularly this portion is actually, it's very important, and this portion is for the business. So if I just make a write of that, the black part is mostly like business looks at there, where if I just showcase this part, the probability of churn and threshold, this is mostly for data science. Okay, so this is comes from a data science perspective. So now move on to a little bit more details what they are. So we know that mostly in this kind of scenario we normally use a classification model. So it could be anything like random forest, right? Logistic regression, XGBoost, XGB, XGBoost, anything you can use it. The model not a problem. The thing is what you are doing is what are the data you are inputting there. That's the main thing. So if it is y is basically equal to function of xi, which is y is what you are looking at, the probability of churn, and then x is your all the independent variable, right? Independent variable. So now you can ask that what kind of variable people look for this kind of scenario. It could be many things in a different use cases. So if it is like a telecom, it could be a subscription cost, then age, demographic, and then it could be happening that is it the time spent on particularly they're looking at how much time they're spending on the calls, and basically their internet consumption, because it's a telco company. Internet consumption. Okay, so anything can be you can go for there. Okay, so now the main factor when you're building this kind of model is basically what I feel is the data sampling. When you're building the model, the sampling, how it works. Why I'm talking about the data sampling? Because this is the area most of the people actually get missed. How? First of all, I would like to talk about little bit about the data sampling. There are 3 main way you do is. One is upsample. Okay, so upsample means, suppose you have you have less sample available, and then you increase the sample ratio for the upsample. So what does it mean is, suppose you have 2:10 ratio between some variables, but you need it more. So in that case, you can make it like 4:10, the sample size. The another one is a downsample. Okay, so in the downsample is, suppose you have 1:10,000 ratio. So I'll come to the downsample later. But then if you want to reduce it, then you can do is 1:100, right? Or 1:10. So that is called a downsampling. Okay. Now the third thing is smooth. Smooth is a synthetic way you generate the sampling. So the full form is synthetic. Okay, synthetic minority oversampling technique. Minority over sampling technique. Okay, so smooth, which is basically how you generate the synthetically the data. So that is basically how it works. Okay, so in this particular area we'll talk about downsampling, because why I will tell you, I'll explain to you. That is one of the main concept people actually missed from the outside, those who actually did not work in the model. So what does it mean is, so suppose you have a 1 million customer, right? It's never going to happen that if you get 1 million customer and because some reason all of them gone in 1 month, not happen there. This is not going to happen. This is very possible. But what happen is, you can lose 100 per month. This is realistic scenario. Okay, but this is also in the business process, again strategy perspective. If that is happening, you have to know why you are losing 100 people per month from a subscription, right? Anyway, so when you are sampling the data, so what will happen, that your actual sample happens, that means which are churn, right? CHURN, and then you have 1 million, so which is 6, right? So this is your ratio, right? If you put it in a model, obviously, if you know data science model, these will be more influence versus this side. So what will happen? It can be overfitted. Okay, for this reason. So better to reduce this amount into such a way, this is the whole thing, that normally in a practice I saw that it might be, if you pick up 10 sample, it should have a 1:9 ratio. So what does it mean? 1 is churn, and then this is non-churn. Okay, or same thing you can do it 15, then 1:14 it will happen. So what does it mean is basically how you resample them, that when you pick up any randomly 10 sample, each time you should have at least 1 churn and 9 non-churn people. Same thing, you can do the experiment with the 15, that anytime you pick 15 customer, there should be the details, basically 1 churn versus 14 non-churn people will be there. Okay, so this is way you can change it to anything like 20. So when if you took it at 20 samples, so then was 19. Basically what I'm talking about, this is come from my experience. So when I build a model, it's basically how it works. It's in that way. Okay, so now we talked about so many things, and then we'll talk about that this concept, how you actually utilize and how you build the model. Okay, so first you get all the data, right? in the data sets, because it's a supervised model, so you'll have a y and all the x1, x2, x3, x4. So the y's will have like 1 0 0 0 1, suppose like to that, and all the variables you will be getting there, right? And then one label it will be saying churn, right? So one means yes, no, 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 yes, right? So these typically you get as a data to work on. Basically you will starting get the data. Okay, so next what you will do is, obviously you will do the EDA. I will not do the EDA step here. Okay, and then the sampling after EDA, right? So in EDA you will decide how many X you want to put it there in the model, right? But that is basically your column. How many sample, like sorry, how many feature you're putting, that means that's decided the column. But then how many rows you will be putting there, right? Normally we know we do 80:20 split, but in this 80:20 split, we have to do the sampling. So the sampling technique that I talked about, it should be 9:1 or 14:1 or 19:1, depend upon anything you can start with there and go on with the sampling technique, right? When I'll do the coding, I'll show more on this part, how you can be getting in details there. So now when you do the sampling from these data sets, then you have it, and you have a y, you have x1, x2, x3, and then again after sampling you have to split, which is for training and testing, train and test, right? And then you'll build the model, right? And when you build the model, basically, if I not wrong, you will be looking at a table similar like this. Okay, this will be your output table. Basically you will be having there. But now the question it comes there, this probability what you are getting here, is actually not the right probability of the right sampling, because you remember it actually had 100 versus 1 million customer, right? But we downsample to 9:1, okay, or 14:1. So now your sample, like that, this probability is actually comes from this sampling, not this sampling. So you have to go back there. So what does it mean is, basically you have to transfer your probability concept or probability value, whatever you got the probability value, the churn value, now is based on 9:1 sample, not 100:1 million sample, but this probability have to transfer this. How you do it? It's called Bayesian probability, the conditional probability one you will be using to transfer this method, the probability to the other probability. The there same table you'll be getting that I showed you before is there. So these particularly concept, these downsampling concept was pretty important from a data science perspective in these particularly churn cases. And then these downsampling, and then going back to using Bayesian probability, that the conditional probability, going back. So you do the downsampling, and then you go back to this probability value. The in a sampling use the Bayesian probability. So this is the theory part. When I'll do the coding, I'll again show you how you can actually practically you can do it and then you will be looking at there. For today, thank you for joining and listening.